Hello students, welcome back. Now that we have the core mechanic of our game in place, our shrinking light zones, we'll work on implementing a resource system that the player will have to manage. Our resource system, we'll call it lumens, just a fancy way to say health or HP. Our player will lose health anytime they find themselves outside of a light zone or in darkness. And when they are in a light zone, they will slowly regenerate that health back. So let's head over to our computer screen and we'll dive right in. I have lesson 4's starter file open here in vscode.dev. I'm going to minimize that browser tab though, and we're going to open our file directly so we can see all of the changes that we make. So here is our starter version of this game. So if I hit enter, we've got our nice shrinking and fading light zone, and it looks like I've got some new stuff in my HUD. I've got a status of whether I'm in the light, but it doesn't update when I'm not in the light. And it kind of looks like I got some HP here, but there's no indication of what my HP is. I don't think my HP is draining because I'm in the darkness right now. So eventually I should probably, die. None of it's happening. So some of our system is here, but boy, oh boy, is it broken. So let's head over to our code and let's see if we can make it not broken, fix it. Yeah, there we go. I was drawing a blank there. I was like, why? What word is this? We want to fix it. So lesson 4, our resource system of lumens or health. Mission number 1, anytime we add a new system, we are going to look at some of the constants for that system that we can work with. I don't even have to do Control F to bring up my tag because we know that those constants are going to live in the student edit zone. The values that we can change, we can tweak to adjust gameplay, how it feels, how it looks. So if we look, what constants do we have for our health system? Well, we've got 3 of them. Our maximum health, our health drain per frame, and our health regen per frame. So how much health are we going to lose and regenerate each and every frame? Well, we got to first set our max health. It's set to 0. That would be really bad of us to give the player 0 health. So I'm going to set it to 100 because I just like that. It's a nice number to work with. Our drain per frame, how much health do I want to lose each frame? I'm going to lose 0.033 of our health every single frame. And we're going to gain back 0.17, so like roughly I think like half of it almost. Okay, so that should look pretty good there. So our constant system variables are in place, which is going to move us to mission number 2. Mission 2. When we reset our game to defaults, we want to make sure that we reset our health variables. Okay, well, those are constants. So what health variables do we have? So if I look up here at my gameplay variables, it looks like I have 2 variables that we are introducing here for our health system. We're introducing a true or false variable called player is in light. This true or false variable is known as a Boolean. All right, so this is a Boolean, a true or false value. So this is going to keep track of whether or not the player is in the light or not in the light. So if they are in the light, that value will be true. And then when they move over here, we'll set it to false. True, false, true, and false. All right, so we've got that variable to work with. And then we have a health variable to work with. So we're initializing it as 0. But when we reset our game, we don't want it to be 0. That would be really bad. We want to give them their maximum health back. So let's take both of those variables. We'll say player is in light. When we start the game, if we start the game, right, if I reset the game, like right now I'm in darkness, and if I reset the game, I want to make sure that that variable gets set back to being in the light because we start in the light. So I'm going to set that equal to true. True. All right, and then we want to update the health variable, and we'll set it to our max health. Because we want to keep this, we're never going to change this, but our health will change. It will drop, it will increase, and so we'll always have a reference to what our maximum health is. Hey, mission number 2, done. Our health system is well on its way. So let's look at mission number 3. So right now we've got like our max health. We are at 100% health, but I want to give some visual feedback that we are at full health. So what we're going to do is we're going to try to draw a health bar right here in our HUD. And as we lose health, that health bar is going to shrink, 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 and shrink. So if we're at like 50% health, the health bar will be 50% full. That will be the visual indication we know we'll have to say like, oh my gosh, we are in trouble. We have to do something here. So let's take a look at mission number 3, which puts me in a function called draw health bar. That's a good function, right? That's exactly what we want to do. So where is this draw health bar? Where are we? So we are in all of our draw functions, right? So in draw scene, which gets called every frame, we are drawing our background, our lights, our player, our HUD, our overlays if conditions are met. And inside of draw HUD, rather than putting all of this code in the draw HUD function, we're calling a brand new function called draw health bar. And so right here in this, I've defined a bunch of just position variables, bar width, bar height, bar X and bar Y, which are going to be the top left corner of the health bar. And I just kind of messed around with these values, but these are just for positioning. The important stuff is right here. We put a paint color in our paint bucket for our text. We set the alignment of the text, and then we put some text on the HUD, HP, and that's exactly what we see right here. Now we need to work on drawing the health bar. So mission 3 is all about drawing the background of the bar, because really our health bar is going to be 2 bars on top of one another. One that is always a set size, and that's going to be our background bar. And then one that is going to change size. It will decrease, and that is going to be our fill bar. So we're on mission 3. Let's do our background bar. So I'm going to put a new paint in my paint bucket because I don't think I want to use the text color. What colors do I want to use? Well, if you're not sure what colors you have, go to your color palette. So I'm going to click like right in here where my color palette is, and let's see what colors we got to work with. Hey, we've got health bar fill color and health bar background color. For the background, I think I'm going to use health bar BG color. It's an RGB alpha string, 255, 255, 255, which is white with a transparency of 0.25. So we're going to see a lot behind it. So let's use this color here in mission number 3, health bar BG color. That's the paint we're going to put in our paint bucket, health bar BG color. And now that our paint is loaded up, I'm going to draw a rectangle. The rect function needs 4 pieces of information. It needs the X coordinate, the Y coordinate of the top left corner. Those are some of my position variables right here, bar X and bar Y. So I'm going to do bar X, comma, bar Y, and then we need the width of the bar and the height of the bar. Hey, I've got those defined for me as well, bar width and bar height. Bar width, bar height. All right, if I run this, let's see, do we get a bar? Hey, look at that. We get a nice HP bar. Although that is one rectangular rectangle, right? It's got these very jagged edges. When I think of a health bar, I think of something that's got more like rounded edges or curved edges. And so the rect function can take in a 5th piece of information, a 5th argument, and it's going to be a number that represents how much we curve the edges. So I'm going to give it 6. And now look at the nice curved edges. And so that fits the look of the game that I want perfectly. All right, so now that background bar is set, and so now what we're going to do is we're going to draw another bar on top of it. When we're at max health, we're going to draw it completely all the way over here. If we were at 50% health, we would only draw it to like here. It's going to give us that visual indication of what our health actually is. So we need to put a new paint in our paint bucket. So I'm going to fill, and I believe we had another health bar cover. We've got health bar background color, and here's health bar fill color. If I look, what is the value? So it's FFE6 6D. So all of the red, almost all of the green, and a fair amount of blue. So red and green, this is going to be like yellowish, I think. But now I want to draw another rect and fill it in with this paint. So I'm actually going to draw the exact same rect I have. Bar Y, bar width, bar height, and 6. So this would like simulate if we had 100% health. I'm just drawing a rectangle directly on top of the previous rectangle. Hey, and there it is. There's my full health bar. But now I want to be able to change this bar. So like bar width, imagine I'm going to change the width so that it's only like half as big, right? It's only like half as big. So imagine I'm going to multiply by a fraction. I'm going to multiply by 1/2. In fact, let's change it. Let's multiply it by 10 over 20 because 10 over 20 is 1/2 as well. Hey, look at that. So now you can see that this would represent having like half of our life. And what if I made it, oh, I don't know, 5 over 20? Well, 5 over 20 is 0.25. And so our bar width is now going to be even less. And then imagine if we gained health and it went up to like, I don't know, 18 out of 20. All right, so this is great, but we need to figure out what values we need here so that this dynamically changes. Well, the denominator is going to be, the bottom part of our fraction, is going to be our largest health value. That's stored in the variable max health. And the numerator is going to be the variable that is related to health that is changing, right? It can decrease as we take damage. It can increase as we regain health. And that is our health variable. So at the start of our game, remember we had set health to our maximum health. So these are the same. So when we divide two like numbers, you get 1. And so our bar width times 1 is going to be the full length of the bar. And there it is. Awesome. Now, as I leave this circle, let's see what happens. Well, nothing yet, because as I leave the circle, I want to begin taking damage. And taking that damage, I should see my health decrease in my HP bar. So let's move to mission number 5 and see if that helps us. Mission 5 says, determine when a player is in a light zone. I guess that makes sense. Before we actually start dealing damage, we got to know, are we in the light or not in the light? So we have to come up with a system that is going to be able to determine if we are in or not in our light source before we can actually deal our damage. So let's go. We are right here, and it is in a function called check object light collision. And it takes in 2 pieces of information, object X and object Y. Oh, okay. Well, let's figure out where check object light collision. I'm just going to explore for a little bit. Let's see where we're calling this. So we've got, okay, so these are our P5 functions, right? Setup runs once when we start our game. Draw runs every single frame of the game. Key press runs anytime we press a key on a keyboard. Reset our game to default. Update player. We've got our update player. Okay. So like we're probably going to, when we update our player, we're going to check to see, every time we update our player, we should check to see, are we in a light zone or not in a light zone? And in fact, if I look here, I think that's what mission 6 is probably going to have us do. So we're going to have to come back to mission 6 to fully implement this system. But let's go back down now. Mission 5, we're looking to see if there is a collision between some object and a light. Well, our object right now is going to be our player. So where you see object X and object Y, think of this as the player's X and the player's Y. So we're looping through every light that we might have. All right, so every light that we might have, right now we only have 1, but we're going to spawn more. And we're going to check to see if our player is colliding with any of them. Now, we got to do a little bit of math here, but the good news is our collisions are going to be super nice because my player is a circle and the light is a circle. So we are going to use circle to circle collisions to help us out here. So let's head over to the whiteboard, and I'm just going to quickly describe how we can determine if 2 circles are colliding. So imagine I have, let me grab a nice pen here. So I have a circle right here, zoop, and we'll say that this is our player. And then I have a light zone, and I'll say the light zone is right here. So the light zone has a center, which has an X and a Y coordinate, and the player has a center, which has an X and a Y coordinate. Now, you could clearly see these things are not colliding. The player is not in the light zone. In fact, there is a line that defines how far away they are. Right here is that line that defines how far away they are. I'll call that line our length, L-E-N. All right, we'll call it the length of our distance between the player and the light source. I'll put the light zone, L-Z, for light zone. So now think of that length as having 2 parts. It has a horizontal part, so I could actually figure out how far are we away in just the X direction. And that would be given by this arrow. And I'll call that dx. And I could also figure out how far away we are in the y direction. I'll call that dy. Now, how do we get dx and dy? Well, dx is just going to be the player's x minus the light zone's x. And how would we get dy? Well, dy, we could do something similar. We could just do the player's y minus the light zone's y. All right, so we can get dx and dy, but how do they relate to how far away we are? Well, there's a nice relationship when you're talking about this shape right here, which is a triangle, called the Pythagorean theorem. And the Pythagorean theorem says a squared plus b squared is equal to c squared. Now, A, B, C, nowhere in my drawing do I have an A, a B, a C, but that's all right. Those are known values for this triangle. We typically refer to this side right here as A. We refer to this side as B. And this side, which is a special side of the triangle, it is the longest side of the triangle called the hypotenuse, we refer to as C. So let's look at what we have. We could actually solve for the length between our player and our light zone using the Pythagorean theorem. We could substitute in. If A is just dx, this would be dx squared. If B is just dy, we'd say plus dy squared. And C is our length, we would say A, the length squared. Okay, but I don't want to solve for the length squared. I want to solve for the length, so I could take the square root of both sides. The square root will cancel out our squared, and we see our length is equal to the square root of dx squared plus dy squared. So how does knowing this distance help us in trying to determine if we are actually in a light zone? Well, as the player moves closer and closer, zoop, 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 that length between the player and the light zone gets smaller and smaller and smaller. And eventually, at some point, the player will cross into the light zone. And we'll say, ooh, maybe there's a collision. Now, the question is, do we want to make this happen as soon as the player touches the light zone? I want the center of the player to be in the light zone. So right here, as long as that happens. So I'm gonna blow that picture up a bit. So here's my player. Okay, there's the player's radius, and then here is the light zone, and we'll say the light zone, the center of the player is right at the light zone. All right. And so that distance, really, it's the light zone's radius, LZ.R, their radius that defines whether or not a hit has occurred. I'm going to call that distance my hit zone. So as our player moves closer and closer and closer to a light zone, this length variable gets smaller and smaller and smaller. And if it is smaller than our hit zone, it means we are now colliding with a light source. We are in the light. So let's write that down. We'll say if, okay, the length is less than or equal to our hit zone, we are in the light. In the light. So let's substitute in our length with our variables. We've got the square root of dx squared plus dy squared is less than or equal to our hit zone. Now, this is great. This works. Mathematically, you are 100% correct. But oftentimes, we don't like taking the square root when we don't have to. And so we don't actually have to take the square root here, because what I can do is square this side and square this side. And squaring a square root will remove that, and I just get dx squared plus dy squared is less than or equal to our hit zone squared. And that is the condition that we are going to look at to determine if a player is in a light source. All right, so we're going to take our dx, how far away they are in the x position, square it, our dy, how far away they are in the y position, square it, and check to see if it is less than or equal to our hit zone. And all our hit zone is, for this example, is just the radius of our light. We could do the radius of the light and the radius of the player, but that would mean as soon as the player just comes in contact, we would say, ooh, they're in the light, start healing them. I'm going to consider that to still be in the darkness, and I'm only going to count it if it's like at least half in the light. All right, so let's go see how that conversation applies to the code that we see here in this check object light collision. So if we look here, remember, we're saying object is just our player. So object X, object Y. So we have a DX variable. And we're saying, hey, take the player's X position and subtract the light's X position. Our dy, we're saying take the player's Y position, subtract the light's Y position. Our hit zone is just the radius of our light. And so with that information, we are asking a question. And it says, if false. Well, folks, false is always false. The answer to that question is always going to be no. So we got to ask a question that is sometimes yes, sometimes no. And that question is going to be used to determine if the player is in the light. We know exactly what we need to do. This is going to be, where is it? Where is it? Our dx squared plus our dy squared less than or equal to our hit zone squared. So let's check it. Let's use those variables. Dx squared plus dy squared less than or equal to hit zone squared. And if that question answers yes, then what are we doing? We are returning a true value. So wherever this question gets asked from, hey, is the player in the light? Did the player and the light collide? If this is a yes answer, we're going to give that back the answer true. If it's not, if we go through and we looked at all of our lights and none of them said, yes, we are in the light, we return true. When it's all done, we return false, which means we are not in a light. Now, we're calling this check object light collision, but I guess we could have called it check player light collision, but we're writing it so that later we can use it for an enemy as well. We can pass an enemy in to see if an enemy is in the light, and maybe the enemy will take damage if they are in that light. So mission 5 is done with a bit of math, but it's done, and hopefully with a lot of understanding. So mission 6 now asks us to update the player's light status each and every frame. So we now have a way to determine if the player is or not in the light, is or is not in a light source. So in our update player now, we've got to call that function. Remember, if I scroll up to our gameplay variables, I think we have a variable called player is in light. Look at that. We're assuming it is true. We set it to true because when our game starts, we are in a light source. But once we move out, we have to update its value. And then when we move back in, we got to update its value. So we're updating something about the player. So right here in mission 6, we're going to take that variable called player is in light. It's either true or it's either false. Where are we going to get the answer to that question from? We're going to get it from the function we were just working in, check object light. So I'm going to start typing and then hit tab to autocomplete. But that function needed two pieces of information. It needed an object's x coordinate and an object's y coordinate. You can see them right there. Well, I want to check to see if my player is in the light. So I'm going to take the player's x property and the player's y property. All right, so let's see what happens now when we leave the light. Ooh, it updates and it says in darkness. We're in light, we're in darkness, we're in light, we're in darkness, we're in light. We're back in darkness. So this system's working really great. Now, where is this code for that change? Well, that's just written in our probably in our HUD. Let's just go to our draw HUD. I bet we'll just see it because you might say, how did that happen? Well, inside of draw HUD, we've got some code right here that is setting the text and setting our color. But that's not part of one of our missions. So let's go to mission number 7. We can now track whether or not we are in the light or not in the light. So that means we can now adjust our health system accordingly, whether or not we need to heal or take damage. So let's see, where is mission 7 going to put us? It puts us in a function called update health. We are defining our data, we drew our data, and now we are updating our data. And let's just verify, is update health getting called every single frame? And the P5 draw function that we got when we imported the P5 library, it runs every frame of the game. As long as our game is in play mode, we're updating the player, we're updating the lights, and we are updating our health system. So that is very, very good. So let's see, it says increase health when in light and decrease in darkness. So we're asking a question. The question is the player in light? That's our variable. It's either true or false. When we're in the light, it's true. When we're not in the light, it's false. So if this answer is yes, we want to add to the health variable. Right now, we're just adding 0. Well, that seems silly. How much do we want to add? 10? 20? 260? I have no idea. Well, I do know because we defined a constant for our health system called health regen per frame, and we're going to put it in there. And if we're not in the light system, so we're going to ask, this is if the answer is yes, we do this. An else statement gives us the option of saying, hey, if the answer to this is no, we now run this code. And so instead of adding, we're going to subtract from the health, and we're going to subtract our health drain per frame. So those are the constants that we defined early on at the beginning of this video. So let's see what happens. I should be able to gain and whoa, my health was growing beyond. That was weird, right? The health went higher than it should have. And whoa, if you look at that, our health is going into the negatives, and it just keeps growing and growing and growing and growing. We don't want that. And now my light's gone, so I can't do this. So you definitely saw it go well beyond zero, well below zero, and you can see it growing past our maximum value there. That's not good. And the reason why is we're running this every single frame. And so every single frame will just continue to add health or take health away if we are in or not in the light. There's no checks here. So what we need to do is say, hey, this health variable should really only be between 0 or our maximum health. And this is where the constrain function comes in. So we're going to take our health value and we'll call constrain. Constrain takes 3 pieces of information: the value you want to constrain, and then the smallest and the largest value that we can take. Basically the range we want to constrain our health to. So we're going to say, hey, if you try to go below 0, you're capped at you're set to 0. And if you try to go above our max health, you are capped at our max health. This should now solve that funny behavior. So if I start my game, all right, my health is not growing above the max health. And let's just see if it drops below 0. And look at that. So it's not dropping below 0. So this is good. In a way. It's good in a way because we fixed one problem, but it has addressed another problem. My health is 0 right now. And, in game worlds, and when your health is 0, you should die. We need to die. We have to trigger a game over when our health hits 0. So let's head to mission number 8. It's our failure condition. Finally, right here still in our update health, we have taken health away. We've changed our health. We have to check to see if it is time for game over. We're going to trigger game over when the health is depleted. End the game when the health reaches 0. So we're asking a question. Hey, if your health is less than or equal to 0. If the answer to that is yes, then what do we want to do? We want to end the game. So how are we going to end the game? Well, ending the game or losing the game is one of our game states. Do you remember we defined a variable right here, game mode, this object, which had 3 properties: start, play, and lose. And we want to switch from the play state switch from the play state to the lose state. So we're going to use a variable. Well, what variable were we using? We were using, those were the constants for our choices. But if we look at our gameplay variables, yeah, there we go. It was called current game mode. See, we had set it equal to start here. And then when we hit enter, what did we set it to? We set it equal to play. And when we restarted the game, we set it back to start. So we used to have a debug here for game over, but we don't need it anymore because now we're going to have a gameplay mechanism end the game for us by taking that variable, current game mode, and setting it equal to our game mode object's lose property. And if that happens, right when we assign that, let's just go look at our draw functions, our draw scene. Right now, this is true, and our lose overlay should draw. So now I think our health system is set. It is complete. So I'm in darkness. I'm in health and healing. I'm taking damage in the darkness. I'm in health. I'm healing. I am in darkness. Oh no, I'm too far away. The light zone is shrinking. And as soon as our health hits 0, we have faded and the darkness has consumed you. I guess I didn't need to say it like that, but that flavor text just begs to be spoken in like that really, heavy tone. We're setting some really cool things here in our game. We now have movement of our player. Our world is set with a nice aesthetic. Our core mechanic is working wonderfully, and we've built a resource system on top of it for our health that adds to the gameplay here. So we now know The light is the safe space that we need to be in, and the darkness brings danger. In our next video, we'll continue to talk about what danger that darkness might bring and how we can enhance our gameplay. So I'll see you in that next video.